Ladies and gentlemen, please welcome our next speaker, Paolo Mainardi, presenting the topic, Building a Trusted and Resilient Software Supply Chain.
Thank you for joining this talk, Building a Trusted and Resilient Software Supply Chain. But before we begin, let me introduce myself very briefly. My name is Paolo Mainardi. I am the co-founder and CTO of SparkFabric. We are an Italian company based in Milan, but we have always operated as a fully remote company. We do a lot of cloud-native custom development and cloud infrastructures, mainly based on Kubernetes. And I am also part of the advisory board of the Linux Foundation Europe, which is a newborn foundation, the European branch of the main Linux Foundation, with the mission to accelerate the growth of open source and open standards in Europe. Feel free to reach me out if you want to know more about the foundation and how to be involved. You can also find me on my personal blog, paolomainardi.com, where I randomly post about things I find interesting, where you can actually download the current slides using that QR code if you want to follow me along. Okay, if you want to take a picture, just some seconds. Okay, let's get started. In this session, we are going to see what is the software supply chain, why it's so important to know today. Then we are going to see the current state of the ecosystem, the threats and the mitigations we can implement with things like digital signatures and software bill of materials. And finally, how to improve the knowledge about our project dependencies and the strategies to choose them more wisely and safely. So to understand what is the software supply chain, I want to start with this very generic definition, which says that a supply chain is a network of individuals and companies who are involved in creating a product and delivering it to the consumers. It's generic enough that can use to describe any kind of product, including all types of software products. However, open source software and the way we build applications today has unique characteristics and threats that make it different, very different from all the other industries and products. This diagram comes from the SALSA framework, slsa.dev, which is an open source project created by the Open Source Security Foundation, the OpenSSF. And this project is not a software framework per se, instead it's a checklist of best practices that we can gradually adopt to improve the security of our digital artifacts. As we can see in this map, the threats are grouped into three main categories: source, build, and dependencies. And attackers usually exploit dependencies as the main attack vectors, which remain the weakest link in the supply chain. Today, it's estimated that a modern project contains an average number or more than 500 dependencies, and that over 90% of our code is not actually coded by us. Now we can imagine with these numbers how much we rely on external unknown actors and how large the attack surface is just on the side of the chain, dependency side. But attacks, as shown in this map, can take place at any link in the software supply chain. And these kinds of attack are increasingly public and disruptive, like the cases SolarWinds, codecov, Log4Shell, and the very recent XZ attack that we are going to see soon. But before jumping into threats, let's try now to imagine the SALSA diagram in action when building a modern application. We, of course, start by very simple, by installing our frameworks such as Next.js, Laravel, Django, Angular, or whatever we like or we have to use. Then the next step is usually to install other dependency from our ecosystem, and depending on how we build our application, we may need other libraries from other ecosystems, such as, I don't know, JavaScript dependencies to build our front-end stack, or Python for machine learning and AI stuff, and so on and so forth. And on top of that, we have our operating system, which is strictly bound to our application. We may need system libraries for compiling additional framework extensions, for example, It's the case of PHP. We may need a specific kernel for things like eBPF or other security stuff. This is quite common in cloud-native applications, or other custom binaries, such as, I don't know, tools for converting images, video, etc. Then we usually have a CI/CD system with a lot of jobs to do linting and QA, to run tests, to collect metrics, and so on and so forth. And pipelines can even use external services as well, like codecov, coveralls, code climate, etc., which means having an external access to our code base and more in many cases, like configuration variables and secrets, and this can be quite dangerous. When our application is ready, we have to ship it on the cloud, where we have several options like AWS, GCP, Azure, Vercel, Platform as Sage, you name it. And when using cloud platforms, we have the flexibility to choose from a wide range of services to deploy our applications, and the services may include Kubernetes, virtual machines, object storage, MySQL, Postgres, Redis, Lambda functions, and so on and so forth. And lastly, we have our local or cloud development environment, which is today another very weird agglomerate of external dependencies, such as, I don't know, the VS Code extensions, JetBrains plugins, VA modules and bundles, or whatever we use to add new features to our devenv. It simply means adding several other external dependencies to our project. It's also very common to have access from our dev environment to the cloud platforms. Maybe because we have to debug, we have to see the logs, we have to check some metrics and such, and this can be quite risky. As we have seen in the salsa diagram, no point in this chain is free of threats, and attackers will try for sure to use all of them, especially when the map of services is so complex and interconnected like this, where we barely know our direct dependencies. What we see here is maybe the biggest case in the history of cybersecurity attacks related to supply chain. This case happened in 2020 to this company called SolarWinds. They are a big IT security company, and one of their flagship products called Orion, a software to perform network monitoring at large scale for data centers, was compromised by a malware that ran undetected for months and then was shipped to all SolarWinds customers as a regular security update. It was later discovered that the compromise was in the SolarWinds build systems, where a vector was designed to inject some malicious code, another vector basically, during the compilation phase of Orion and then hide itself again. This is exactly the point C described in the Salsa framework, as you can see in the image. The biggest tech giants like Microsoft, Intel, Cisco were affected by this vector, but even the most important national security agencies like the Pentagon, the Homeland Security, and other important public entities and worldwide national states. This case was so big and concerning that the US Congress invited SolarWinds CEO and Microsoft president to testify on the case to understand why companies that are supposed to protect us from this kind of cyber attacks were instead themselves victims of a long-running global and large-scale attack like this. And just some months after the SolarWinds case, in 2021, a critical security vulnerability was discovered in the Log4j library. Log4j is the standard factor for logging in the Java ecosystem, and it is basically always present in all Java code bases, either as a direct or a transitive dependency. Some have defined it as the most serious software vulnerability ever, and according to the Washington Post, it borders on the apocalyptic. Let's see why. Log4Shell is a vulnerability with a severity score of 10, the highest possible, because it allows remote code execution just by injecting a specially crafted string in the HTTP headers, so it's quite easy to replicate and to exploit. Super easy, actually. And to make the scenario worse, almost immediately after the disclosure was made public, multiple proof of concept were published on GitHub. And from that moment on, organization had basically 0 days to respond and mitigate the threats that started. But the good news is that from 2021 to now, more than 3 years later, everyone has updated and the issue is almost gone. Everyone has updated, right? The fixes were released 3 years ago. Well, it's not that easy. This is a fresh snapshot from Log4Shell download dashboard made by Sonatype, and this data clearly shows that 35% of the total downloads just in the last week were a vulnerable version. And we are talking about more than 4 million downloads weekly. This is a clear indicator of the fragility of the open source supply chain and how it's hard to eradicate critical vulnerabilities even when they are public and the fixes are made available years before. And now fast forward to April 2024, just 1 month ago, for another important, well-organized and quite scary supply chain attack. Defined as the best executed supply chain attack we have seen described in the open. In this case, was even discovered totally by accident. Let's see how. This story begins on March 29th when Anders Freund, a Postgres developer working for Microsoft, posted this message on his Mastodon. While he was doing some micro benchmarking operations, he saw that some SSHD processes were consuming many more CPU cycles than usual. So he got very suspicious and started to profile them. And just some minutes later, he sent this message on the OSS security mailing list announcing his big discovery. Basically, he found that someone planted a highly sophisticated vector in the XZ library with the intent of compromising OpenSSH. If you want, you can scan the QR code to access this message. This is a very interesting, detailed explanation of what this vector does and how. But let's take a step back and see what is XZ and how SSH has been impacted by this library. XZ utils are open source projects that implement LZMA compression algorithms that are widely used in the Linux ecosystem. Even the Linux kernel is compressed with this format. OpenSSH does not require XZ, but some Linux distributions patch it to support systemd notifications, and the result at the end is that OpenSSH depends on libLZMA2 as an effect of a transitive dependency. This is a textbook example of software supply chain risks related to dependencies. But the scariest side of this attack is that it required over 3 years of work to complete by a group of attackers. In 2021, someone named Jiatan joined GitHub and made his first commit to an open source project out of the blue. Some months later, he became a co-maintainer of the XZ project thanks to his apparently legit work, but even thanks to a pressure campaign started by some new users who joined the development mailing list of XZ just to accuse and blame the project maintainer Lasse Collin to not update the project fast enough. In the next 2 years, a series of new patches got merged to XZ, which now, in retrospect, they just look like as groundwork for the future backdoor, but at the time they were quite good. And when everything was considered safe and well hidden, Jiatan dropped 2 new releases with the backdoor inside. In the following weeks, Jiatan and his group pushed developers of Ubuntu, Red Hat, and Debian to merge the new XZ release, and eventually they were actually merged in the development branches, ready to be deployed. I don't know why it's missing a slide. And for sheer luck, the nightmare story ends here. Anders unveils the backdoor and XZ gets reverted from Linux distros. but only thanks to its nature and the fact that open source means open access to any code base, basically, that Andres Freund was capable to discover by accident this vector just a few days before it was widely deployed with extremely dangerous consequences. But the incredible part is that he found it just because his machine was suffering a very little slowness. But the other side of the coin is that open source can be unsustainable for maintainers, who sometimes are required to work under very stressful conditions, even they are working for unpaid hobby projects, and maybe those projects are critical like XZ. This is exactly what happened here, where the maintainers who was suffering from burnout. You can see this message posted by the maintainer Lasse Collin to the mailing list at the time in 2021, when decided to give Giatan a bigger role in the project because he looked like just someone to trust. He was helping the project, he was pushing patches. In this case, it's a big security wake-up call for everyone involved in open source, both as consumers and contributors and maintainers. Since 2019, attacks like these have increased by more than 700% per year. This is a graph from the Sonatype report. And the first reason is a great global demand for software. Okay, I skipped that slide, and well, we know that there are a lot of global threats and they are increasing a lot, and all these reasons together led government to work on new cybersecurity laws. US government promulgated the National Cybersecurity Strategy almost 1 year ago in March 2023, which is a long-term strategy to improve the security of organization, and explicitly talking for the first time in the history of computer science about making software vendors liable for insecure software. This is a giant step forward for the cybersecurity liabilities. The EU Commission also worked on a law that is called Cyber Resiliency Act, the CRA. You will hear a lot in the next years about this. And the purpose of this law is basically to regulate all the products that incorporates digital elements, which includes any product that can run software. It is the equivalent of the CE mark that we see in electronic devices since years, but specifically designed for software. It will have a huge impact on the software industry. If you are interested in this subject and you want to know more, you can just follow the link you see on the slides or scan the QR code, and you will find all the Linux Foundation Europe and other foundations initiatives about the CRA. But the good news is that even the response from the community has been strong and well coordinated. And one of the responses has been the creation of the OpenSSF, which is a not-for-profit and cross-industry organization formed in 2020 and part of the Linux Foundation. The goal is to set basic security standards for all open source projects. And the way to achieve that is through a combination of tooling, education, and extensive automation. And one of the biggest issues, with security, especially in open source, is where maintainers, with their limited personal time, have to choose between new features, bug fixes, and security enhancement. We just see the accident Z case. This is why automation and low integration friction are crucial for a sustainable and widespread adoption of security. We see some of the mentioned projects in this slide and how they work in a moment. Well, now that we have a general overview of the software supply chain and the main threats and how dangerous they can be, let's see what we can do to mitigate them or even anticipate or prevent them, starting with improving the integrity and trust in our dependencies. So the first question is, what is the trusting model between us and the digital artifacts that we are going to use? How can I be sure that what I'm running is really what it claims to be and coming from a trusted source? Well, it is essentially the same question Ken Thompson proposed in 1984 in his famous paper, Reflections on Trusting Trust. And basically the answer is that we cannot really trust the code we don't totally write ourselves. Instead, we should put more trust in the people who wrote it. Maybe it was possible when Ken Thompson wrote this paper, but today, considering the big amount of use dependencies, it is a pretty impossible task. So, to enforce the integrity and trust, we need to know who built, when, and how the artifacts we are going to use, using things like digital signatures and software attestations. And we also need to know the list of things who made the artifacts, which is basically like the list of ingredients of food. Using digital signatures with key pairs, we can solve the first set of problems totally, because they ensure integrity, authenticity, and non-repudiation, which are the key elements in building trust between known and unknown actors. But the problem is that managing keys is very hard and boring, because we have to deal with distributing the keys. We have to keep our private keys in a very secure place. And if, or better, when they are compromised, we have to revoke the old keys. We have to inform our network of users and start the process again and again. This is why digital signatures are not yet widely used by end users, even though they have existed for decades. But there is a new project called Sigstore from the OpenSSF, which aims to fix all these issues related to managing keys. Their goal is to be what Let's Encrypt has been for TLS certificates. One of the ways Sigstore allows to sign artifacts with keys, it is implementing a keyless signing approach. It works by using a public identity like GitHub, Google, or whatever OpenID connects provider to generate a short-lived certificate and use it to sign on your behalf. So we can get rid totally of managing keys, having public and private keys. We need just our public profile. And another interesting feature is that signatures can also be stored in the OCI registries alongside container images, removing even the distribution issues. The other key element in the software supply chain are the software bill of materials, known as SBOM. They represent the list of ingredients who made the artifacts. We can use it for things like vulnerability scanning, license policy, find abandoned dependencies, so on and so forth. But generating software bill of materials is a very, very complex task, because dependencies live in different layers and they are managed by different package managers, and they differ a lot in how they package stuff. But there are some tools available that can help us with this very tedious task of generating SBOMs. The most advanced one are Syft, Grype, and Trivi that we can use on code bases and containers to generate the full software bill of materials and vulnerability scanning. And recently, even Docker has a built-in SBOM generator, which eliminates the need to install an external tool when you deal with containers. Now, we have seen the importance of digital signatures and software bill of materials and how to generate them to help us to improve the trust, the integrity, and transparency of our artifacts. But how can we wisely and safely choose our next project dependencies while still navigating the vast oceans of open source libraries? Yeah, vulnerability management is still one of the major issues, and this issue is caused by a big fragmentation of the ecosystem and not actual easy ways to automate the tracking and the issuing process of vulnerabilities. So OSV was created to address all these challenges, and OSV is a project born in Google and now is part of the OpenSSF. It consists of a new data format, the OSV schema, which is designed to contain information like versions, package names, and ecosystems, with the intent to make this data more easy to consume, both for machine and for humans, and more open source specific. The other key element is the OSV database and its free API, which is a database of known vulnerabilities populated from various sources with the goal to provide precise and actionable information that we can directly integrate in our development or security workflows. It is very well adopted. It supports the biggest ecosystems such as Go, Rust, Python, Java, Node.js, PHP, and the major Linux distributions. Another important aspect of picking up new dependencies is how to understand the overall quality of projects, not just in terms of code quality, but even about their security practices, the contributions, the active maintenance, if they have continuous integration in place and how is the state, and in general, any non-functional aspect that is part of the quality equation of a project. Doing all those checks manually, and for each dependency we use, it is almost impossible for a human being. And this is where OpenSSF scorecard project comes in help. It consists of a set of automated checks that anyone can run on any project by using the CLI or by integrating it in a CI/CD pipeline. And each check returns a score out to 10 and a risk level. When they are used, then they are used to calculate an aggregated score to represent the global project score. And alongside the score, this tool also provides remediation prompts to fix the discovered issue, and this is quite and super handy, especially for contributors and maintainers, And still talking about tools to help us better understand our dependencies, Open Source Insight or devs.dev has some very unique and interesting features. It is a project developed and hosted by Google with the goal to provide dependency analysis for open source projects. For each project, we have the complete dependency graphs, security advisories, all use licenses, and the OpenSSF scorecard data. The services. This service at the moment supports different ecosystems such as Rust with Cargo, Go, Maven, NPM, NuGet, and PyPy. And as a bonus, the data are accessible for free via an API, so you can easily integrate those data in your development or security workflow. Another very interesting project is Guac from Kumari. They recently joined the OpenSSF as an incubating project, and Guac stands for Graph for Understanding Artifact Composition. And it's a sort of database that collects data and insight of our supply chain. And it works by ingesting security metadata like software bill of materials and attestations. And then the data are extended using external sources like OSV and deps.dev. And finally, everything is interconnected as a graph. The result is a database that we can query using the Guac CLI or just using the GraphQL query API exposed by the system. And another way to see the data from Guac is the Graph Visualizer, which is a utility for visualizing and interacting with the supply chain graph from a browser, where we can filter by package type, such as Golang, Python, JavaScript, or by using namespace, package name, its version, or highlighting the graph, the nodes graph, using some attribute like SBOM, vulnerabilities, etc. And it is a very nice companion for graph explorations and may be very helpful in different situations, I don't know, like demos, trainings, and quick and dirty data analysis. What if we could have something that automatically manages dependencies for us? Maybe even opening, reviewing, merging pull requests with security updates, minor upgrades. Is it something magic? No, because both Renovate and Dependabot can do that, and they can do much more. Renovate is an open source project that we can use basically everywhere. while Dependabot is a GitHub native project. But they share, at the end, a similar set of features and the same goal of automating the entire life cycle of our project dependencies. I suggest you to try them as they are very straightforward to integrate. It's just a click, Dependabot, basically. And they can cover from simple to more advanced scenarios. So, just some takeaways, as we saw a lot of stuff, a lot of name, a lot of foundations, a lot of project. Software supply chain risks are a real threat, and they will increase in the future a lot, especially now that the global demand of software is growing a lot, and open source is the standard de facto for developing. We can improve the integrity and the knowledge of our dependencies using modern cloud-native tools supported by open source foundations as OpenSSF, using tools like Sigstore, Syft, Grype to sign and generate our SBOM and check for vulnerabilities. And thanks to projects like OSV, Scorecard, and devs.dev, we can choose our next project dependencies way more safely and informed than before. And finally, we can automate project dependencies lifecycle using tools like Renovate or Dependabot, so we can get rid of the most boring tasks like upgrading dependencies, and also to be quicker to integrate security fixes as they are, or critical fixes as they are publicly released without doing nothing, basically. And as a bonus, I have recorded the demo that you can find scanning the QR code or following the link, where I will show you all the tools in action, how to use Sigstore to sign a container, how to generate the software bill of materials and scan for vulnerabilities, and the strategies we have to reduce the attack surface and the number of dependencies and vulnerabilities when dealing with containers by changing the base image from the standard ones, I don't know, like Debian, Alpine, from smaller ones like Distress or ChainGuard images. So, I am done. Thank you very much for your attention. So, are there any questions? Yes. In your opinion, what could be the solution to supply chain attack? I think all the things we have seen so far, they are things that we can do to improve our security supply chain management. There is just one solution. We have to deal with many threats, starting from dependencies to all the other things that we have seen. Can free open source solutions substitute services like Snyk or Sona type solutions, or do paid services perform better in any way? But I don't think that they are one can substitute the other, depending on your use case and how budget you have to build your own solution using open source software, because they are quite easy to use, but you know, when you have to integrate your new open source software in your workflows, it costs a lot, and maybe it depends on the use case. They are very good services, the commercial ones too. Truly helpful presentation. Can you share it? Yeah, I will share it. You can also find me on my personal blog, but I will share on the Dropbox folder that organizers have shared. Is private Artifactory something like JFrog worth the effort? I think so, because as far as I know, they already have something in place to do vulnerability scanning, generating software and bill of materials. So yeah, they can worth the effort. Which ecosystem has the best protected dependencies? Linux or macOS? NPM or Cargo? Debian or Windows? Who is the leader in supply chain attack mitigation? Okay, which ecosystem best protected dependencies? I don't know. I think that any open source ecosystem has the same threats. Maybe Node is the worst one just because they have as is designed Node and npm. They have very small libraries, so when you install a package like React, basically you get like 500-600 dependencies, but it's just a number, not because the code is worse. And Linux or macOS, the best I think that is Linux because it's open source. npm or Cargo, as I said, maybe Cargo it's better just because the dependencies are created in the Cargo ecosystem instead of Node, which is famous for having a lot of dependencies, and Debian or Windows. Debian because it's open source and we know everything behind the supply chain of Debian. We don't know basically nothing behind the supply chain of Windows, neither macOS. And who is the leader in supply chain attack mitigation? I don't know. You are the next leader. I don't know. I don't think that there is one today. Are there any other questions here in the room? So, thank you very much.